Hello and welcome. This is Safa. In this episode, we bring everything together into a full mission simulation of an autonomous underwater vehicle under realistic disturbance conditions. The goal is to make the AUV follow a complete trajectory while now facing realistic external disturbances. We will compare standard slow control with the Disturbance Observer-Based version. We simulate the AUV in two-dimensional planar motion with an S-shaped mission path over 60 seconds. Disturbances are modeled as sinusoidal wave combined with the random noise. As in the previous episode, we will test both controllers. Pure SMC is robust but struggles with sustained disturbances, while DOB-SMC can actively estimate and cancel them. We expect that pure SMC will deviate when disturbances are strong, while DOB-SMC will provide smoother and more accurate trajectory tracking. Now let's switch to MATLAB and implement the full simulation step by step. Okay, parameters. Here we define the AUV parameters and math and damping matrix as well as the simulation horizon. Okay, mission path. The reference path is chosen an S-shaped curve, which is more challenging than a simple circle. And then disturbances are modeled as a sinusoidal ocean wave with added gasoline noise. Initialization, we set up the initial state for both controller and for the disturbance observer. And here controller gain, and simulation loop, a sliding variable, pure SMC controller, DOB-SMC controller, and dynamic update. The vehicle dynamics are integrated with Euler method, updating velocities and positions. Disturbance observer continuously estimated unknown force and improves control performance, and plots. The final plots show trajectory tracking, disturbance estimation, and position error. We can directly compare pure SMC, DOB-SMC. Okay, and run. Okay, in this full mission test, DOB-SMC successfully performs pure SMC under strong disturbances, achieving a smoother and more accurate trajectory tracking. This validates its usefulness for real-world AUV mission. Okay, thanks for watching. This is Safa. We're learning together one concept, one line of code at a time.